A portal is a special kind of doorway that doesn't just lead you to the next room, but can take you to a completely different location, regardless of distance or obstacles in between. This concept was theorized by numerous science fiction books and movies. Let's explore the most popular implementations of this concept, testing all edge cases to decode the mechanics and algorithms behind portals. We will also build a simple demo ourselves to illustrate these principles in action. We will begin by defining the essential properties of portals. First, portals transport you from one position A directly to another position B, so it's essential to store each portal's position as coordinates. Note the getPosition method that will be of use to us shortly. Portals aren't generally a one-way ticket. They work both ways, and thus must be linked bidirectionally, as demonstrated in this example. This is why the link method sends the linked portal field of each portal to reference the other portal. The actual teleporting part is easy. Just set the player's location as the portal's location from the previous getPosition method, and in the case where a portal is not linked, nothing should happen. Now all we have to do is call this method when a collision between the user and the portal is detected. One more thing we could do is maintain the user's velocity as well as adjusting its direction to match the one of the exiting portal. Here is our demo up until now. I personally think Python works best for quick demos. Here the portal gun is simply implemented by calling the portal constructor for coordinates positioned directly in front of the player. A special case is when a portal is attached to a moving platform. This portal should move with the platform and teleport the player to the updated coordinates. First, let's create a platform class with a move method to control its movement. Then we edit the portal class, employing a concept called composition, meaning the portal has a platform. This approach is effective because the platform coordinates will update automatically when using move. All we need to do is add that with the static offset, which represents the portal's position relative to the platform's origin. Here is the updated demo. Before we wrap up, I would like to talk about one last implementation. Take a look at this sequence from Little Nightmares 2. At first, it feels like you're trapped in an endless loop. After all, there are only two doors, and whichever one you take, you will end up back in the same room. But in this puzzle, the hint is actually the faint music that guides you towards the right door. This is not just a magical room. This is actually a finite state machine, with multiple states represented by these identical rooms. The game is waiting for you to perform a correct sequence of actions to reach the end. Take the right door and you move forward in the state machine. Take the wrong door and you get sent all the way back to the starting state, room 1.